About 70% of Earth's surface is covered by ocean, which is constantly in motion with natural kinetic wave energy. Thus far, the enormous amount of energy in the motion of these waves remains virtually unharnessed. The origin of this energy is about 150 million kilometers away. A very small percentage of the sun's radiation shines upon our tiny planet. This radiation causes more motion of the nitrogen and oxygen molecules that make up the bulk of our atmosphere as it shines through to the Earth's surface. This molecular motion, or heat, makes the air less dense. Water vapor is also evaporated from the oceans by this heat from the sun. As this warm, humid, and less dense air rises against the force of Earth's gravity, its space is claimed by surrounding cooler and more dense air. Due to the rotation of the Earth, this cooler air tends to blow in to replace this humid, rising warmed air in a circular manner, counterclockwise north of the equator and clockwise in the southern hemisphere. This relative motion of air masses is what we commonly call wind. Concerning the harnessing of energy for a usable purpose, the Earth's atmosphere has concentrated the sun's energy to the order of tenfold. In other words, there is about 10 times as much energy flux there to be harnessed by a windmill than a solar panel. This sun-driven concentration of energy by the Earth's atmosphere is being used to our advantage by wind turbines to generate electricity all over the world. A wind-powered turbine harnesses the natural motion of our atmosphere without polluting it. The Earth has not yet finished concentrating solar energy for us to harness by the nature of wind. As the wind blows over the vast expanses of our oceans, it agitates the water surface. In combination with the Earth's gravity, these vast distances, known as fetch in oceanography, create common wind waves. Unlike the tides caused by the gravitational pull of the moon and the sun on the oceans as the Earth rotates, the familiar common wind waves are an indirect result of the sun's radiation. In classical mechanics, the basic formula for kinetic energy is 1/2 of the mass multiplied by the square of the velocity at which the mass is moving. This formula works well where m is a solid object of known mass and velocity. Using compatible metric SI units, a mass in kilograms and a velocity in meters per second yields a solution in joules, a metric unit of energy. When considering the flow of a substance, the mass per unit time is used in place of the mass alone. This is the formula for power. Using compatible metric SI units, a flow in kilograms per second and a velocity in meters per second yields a solution in watts, a metric unit of power. Watts also have an electrical equivalent, and by the laws of physics, there is never more electric power generated than there is available in the mechanical source that drives the generator. Water is 700 to 900 times as dense as air. This means that the power of moving water is 700 to 900 times that of wind blowing at the same speed. Hoover Dam is capable of producing over 10 terawatt hours of electricity in 1 year. Conventional hydroelectric has proven thus far to be the most cost-effective, clean, and safe way of producing large amounts of electricity for distribution. In fact, the top 4 electricity production facilities in the world, in terms of wattage, are all hydroelectric. Precipitation over land has been harnessed for centuries as Earth's gravity pulls the water back down to sea level. But once it gets there, there is obviously still motion remaining, often violent motion. What is the best way to harness this type of motion? A tremendous amount of energy is obviously there. Other inventors have developed ideas to capture the motion of ocean waves. Yet we at Ocean HydroElectric have a unique system and method for capturing this energy for a usable purpose. I am the inventor for Ocean HydroElectric, and my ideas explained in this presentation are legally protected by the United States Patent and Trademark Office and the World Intellectual Property Organization. These ideas that I have been developing since 2008 have been improved upon due to experimental results using miniature partial prototypes. The question I've been trying to answer is how to most efficiently capture the motion of water waves, transferring it to the rotation of a wave-driven turning axle. Here we see the natural motion of particles in the side view of passing water waves. Notice the motion at the water surface. The most efficient way to harness this motion would be to have machinery mimic it, to move along with it, driving a mechanical load. Ideally, the best way to harness the energy is to stop the motion, with machinery driving generators or a pump. From a wave-driven axle, this load could consist of generators driven through a transmission or a mechanical pump. What sort of machinery could rotate as it moves forward, just as the water does within a wave? I begin to answer this question with what I call a wave spool. Each wave spool will have a polar array of moving curved paddles and a spur gear on each side. This cutaway view of a wave spool shows how when the circular motion of the water in a wave pushes the paddle to its maximum radial extension, the paddle locks into place, driving the wave spool around its central axle. If water is moving slower than the wave spool is turning, the paddle hugs against the center of the spool and the adjacent paddles, reducing drag against rotation. Another look at the motion of a particle within a wave shows that in addition to the circular motion, there is also a forward transitional motion of the wave. If the spur gears on the wave spool are coupled with a pair of rack gears, the wave spool is now able to follow the motion of the water. This allows the wave spool to remain within the wave, moving forward with it and gathering more energy from it. Each wave spool is rotatively attached to a pair of duplex roller chains. This could drive the load that consists of a conveyor that drives the end mechanism of use, a group of generators, or perhaps a mechanical pump. This conveyor could consist of supporting sprockets and rollers, which are in turn supported by the appropriate axles and bearings. At least one of these axle assemblies would need to be a drive axle assembly. The rest could be idler axle assemblies. The idler axle assemblies would serve the purpose of low friction support of the conveyor. The at least one drive axle assembly is to transfer the load to the driven useful purpose. For this example, assume there are two drive axles, one on each side of the supported conveyor. Each drive axle could be coupled with a flywheel and transmission to drive electric generators or a mechanical pump for the desalination of ocean water. All of the axles could be supported by two movable walls. The machinery described thus far can be referred to as the wave spool conveyor. The supporting walls of the wave spool conveyor are designed to be lifted up and out of the water for transport and maintenance. The wave spool conveyor could be supported by a double-hulled ship. One end of the hulls of the ship could face oncoming waves while in operation. The ends of the ship hulls facing the oncoming waves could be shaped as to guide the incoming waves into a channel between the hulls of the wave spool conveyor to extract energy from them. The hulls of the ship need to act as a wall to guide and enhance the waves as opposed to riding over them. To achieve this, the entire vessel will need to be multiply anchored to the bottom of the ocean by tensioned cables. To maintain this tension against the vessel's buoyancy, these anchors will need to be bored into the sea floor. The tension in these cables will increase substantially with a large vessel as the tide rises. This tension in each cable could be relieved through a transmission to drive extra generators. The option of having the wave spool conveyor fixed to the bottom with pylons also remains viable. Of course, bigger waves contain more energy. The amplitude of the waves could be enhanced where the energy is being extracted by what I call the wave enhancement channel. The two top edges of this device could be attached to the liftable supporting walls of the conveyor. The surface of the wave enhancement channel will consist of an array of one-wave valves. This allows water to enter the channel through the valves and add to and enhance the wave while preventing water from flowing out to diminish the wave. The beveled end of the wave enhancement channel helps guide more of each wave between the ship hulls and supporting walls to drive the wave spools to cycle the conveyor. The wave enhancement channel could be used to enhance wave amplitude for other types of wave energy converters. The wave spools could be rotatively attached to the pair of duplex roller chains by three possible methods. The simplest method would be specialized roller bearing containing links within the pair of duplex roller chains. The conveyor could also be automated to accommodate variations in wave period. I have designed two types of sprocket idle lock mechanisms, or SILMs. One SILM being mechanically triggered by a lever, and the other being triggered by the presence of a magnetic field. With a system of sensors, one attached to a buoy in the vicinity of waves approaching the conveyor, either type of SILM could be used to time the conveyance of the wave spools to match the spacing of approaching waves. When in an idling position, the SILMs will allow each wave spool to remain stationary as the pair of duplex roller chains pass through the SILMs. When in a locked position, the SILMs will allow each wave spool to drive or be driven by the conveyor. Both types of sprocket idle lock mechanisms may prove to be useful and marketable inventions outside the realm of ocean wave energy. Wherever timing of a conveyor is needed in industry or agriculture, these inventions could accommodate that need. One of the best known energy converters is the Polamus. The Polamus drives electric generators with hydraulic pistons fitted between its sections. As the sections of the anchored Polamus ride over passing waves, these pistons drive electric generators. The generated electricity is sent to shore and grid via an undersea cable. The Polamus has been put into practical use off the coasts of Portugal and Britain. How efficient is this device? One can see that the size of the waves remain virtually unchanged upon passing the Polamus device. Mechanical energy and motion are one and the same. It can be seen that a very small percentage of the available energy has been extracted from these waves that have passed the Polamus farm. Regardless, the Polamus is a pioneering example in the field of ocean wave energy conversion. Other devices that harness the oscillatory motion of a buoyant object have been put into practical use in electricity generation. This land-based device is in operation on the coast of Brazil. Here again, very little of the available motion or energy is taken from the waves. Another type of wave energy converter is the Wave Dragon. This device guides waves using reflectors up a ramp where water is sloshed over a wall into a collection reservoir. The pooled water turns turbines as it drains back to sea level. This is the age-old idea of harnessing falling water. This comes from the equation mgh equals 1/2 mv squared. This is the equation of potential and kinetic energy, where mgh is the potential energy. M is the mass, G is the acceleration of gravity, and H is the height at which the mass is due to drop. With a height of 2 meters at best for the water to drop back to sea level, compared with over 221 meters in the case of Hoover Dam, it is not surprising that the Wave Dragon only generates a minuscule amount of electricity comparatively. Much as the technology of aviation was 100 years ago, the current field of ocean energy conversion is in its infancy. If necessity is the mother of invention, the necessity is certainly here today. With over 7 billion people on this planet striving for a modern existence, humanity has resorted to means of electricity production that not only endanger our existence by polluting our environment, but to extremes that endanger the continuation of life. There is also a growing need for fresh water worldwide. If you have interest in investing in further research and development of these ideas, you can contact us at www.oceanhydroelectric.com.